Hi, everybody. Thank you for being here. We're here hopefully with a talk that's going to actually help you be a better developer tomorrow, right? And so we're going to talk about the React framework. React, in my opinion, is one of the best frameworks for user interface development. If you look at different Google Trends, it's one of the most popular ones. Now, the other popular frameworks like Angular, I give Angular a lot of credit. It does much better security, and a lot of the later designs of Angular are actually very decent. But if anyone here, has anyone here ever used Angular 1 before? Once, what did you think of Angular 1? Exactly, the maintenance cost of Angular 1 was so expensive, I bailed on it. And even though they fixed those problems, I'm very Sicilian. I will never forgive Angular for the sins of Angular 1, and it's dead to me now. So now, I do all React. And I think from a usability point of view, React is amazing, but the security properties of React are not as good as other frameworks. So unfortunately with React, we have to do security engineering, especially as you get deeper and deeper into React and use some of the more nitty-gritty features, you have to understand security engineering. And that's a shame. And there's a chance to fix these things in React, but they simply haven't done it. And we're at what, like 18.3 right now? And these holes all still exist in the current versions of React. So we're going to look at, like, what is React, right? We're going to look at, like, what are the top security domains for this framework? And we're going to look at, for each one of the React security domains, we'll look at key concepts, some challenges, we'll look at some examples of good and bad code, and we'll come up with a clear protection strategy from a software engineering view so you can build bulletproof React applications from a security point of view. My name is Jim Manico. I'm a former board member of OWASP. I've been a developer for almost 30 years now. I'm an author in the security space, and I'm a project leader for a couple OWASP projects, but I'm primarily an educator now. I now travel the world and teach developers how to write secure code, and I love my job. I feel very grateful that I get to do what I do in the world. I love teaching. My great-grandfather was a professor. My grandfather was a history professor. My father teaches accounting, boring, but he's a funny professor. And so I'm following the lineage of my family 4 generations later. I love what I do. So we know what React is. It's a JavaScript library that's primarily used on the client for user interface development. There's also server-side rendering of React. And I don't want to offend anyone, but I found something out recently. Yeah, he's like, yeah, I know it. Yeah, you're going to try to offend me now. It's kind of hard to believe, but some people actually use JavaScript as a server-side language. Oh, that hurts me to even say those words. Yeah, I know. So there is some server-side rendering of React with Node. Oh, Node offends me. All right, so let's just move on. So here's the biggest attack against React. View source. What should I never see in your client-side React code? This is the first question to start with. What should I never see in your client-side React code? And there's a lot of things. Number one, I should never see any kind of hard-coded secrets like API keys. I should never see any kind of access control. Let me ask you this. When you're doing client-side React, how much access control logic should be in your code? Anybody have an idea? How much? Zero. Guess how often I see that principle actually followed in the real world? Almost never. If you're an admin, show the admin link. If you're not an admin, don't. And I see this in almost every React app. I see hard-coded secrets. I see, well, you can't attack us. We have API protection. But you are my favorite, and you are my favorite. The amount of access control that should be in your client-side React code is 0. It should purely be a view layer. Why is this? Because I can look at all your source code. And if you hide stuff from me, there's nothing that you can do to stop me from seeing that access control logic, exposed links, exposed forms. I got called on the carpet for this idea recently. I was looking at a React app. There's a cookie. I see in the cookie, access equals user. Really? So I flip it to admin and refresh, and I get the entire navigation pane, right? This is a gambling company in Europe, a big one too. And I'm like, oh, this is a critical vulnerability. I analyze it a bit. This is a critical vulnerability. And they're like, no, it's not. Several people have pointed this out to us. It's not critical. I'm like, I know it's critical. I'll bet you. They're like, bet? So here's the deal, Jim. They said, if you're right and we agree it's critical, we'll double your pay for this week. And if it's not critical, then you're free this week. And I'm like, you have a deal. Give me a contract to show me this. And they did. And I'm like, it's on. So I present in front of the CEO, CTO, the CFO, and their security officer and a few lead developers. And I'm like, it's Manico time. It's game time. So I open up their app, register a new user, go to the cookie editor, flip it to admin, and see the admin console. They're like, well, prove it to us. So I go to every single admin feature and try to do an admin action, and the API blocks me. And they're like, see, we told you. And I'm like, so you don't think this is critical? They're like, nope, it's not. I'm like, deal. So I open up a live Google Docs document. I'm about to steal some of your data since it's not a critical issue. And I just registered a new account. I could be anyone in the world. I go to one of their admin features, Edit Customer. So Edit Customer was an enterprise feature to let some employees bet on football games, otherwise known as soccer in America, right? So this is an enterprise feature they have, and I'm like, hey, take a look what's on your Edit Customer page. A drop-down list of every single one of their enterprise customers and an amount in euro of how much money they're spending. And I'm like, holy cow, your entire enterprise customer list is there for any user. And since this isn't critical, I'm gonna go grab a copy of this. So I cut and paste their entire enterprise customer list, several hundred companies. And I'm live in the Google Doc, and I'm like, the moment I hit paste, it's my list. So what do you think, C-level staff? Is this a critical vulnerability or not? Because if you say no, I'm gonna paste and take this data away from you since it's not critical. And the C's are looking at each other like, pay them. All right, Jim, I'm like, boom. They were they didn't throw me out of the building. They still let me work with them. They were impressed with my little show. But that's the problem when you start exposing admin logic. You're going to expose admin metadata that's severely problematic, at least, right? And also, unsafe React lifecycle methods. I don't see this that much. Direct DOM manipulation. All right, React developers, what is wrong? Stop using refs. Enough with the ref to edit the DOM directly. We have React to do this. There's never a good need to actually edit the DOM with the raw ref. That's direct DOM manipulation, and you skip all of React security. Or inline scripting in the eval function. This is not a necessary programming technique at all. Or using props or types from untrusted data without doing proper data validation or sanitization. Or storing sensitive data in client-side storage like local storage. There should be where is a good place in a client-side web application to store sensitive data long-term? Come on, you want to go for two? Where is a good place in a web browser to store sensitive data long-term? Nowhere! Same answer. So putting sensitive data into things like local storage is a critical anti-pattern. Or using deprecated third-party React plugins. I think React is a good framework. But the ecosystem of third-party React plugins, who uses those a lot in development? Here's my opinion of that ecosystem. It's a morass of insecure filth that no one should use. That's the majority of it, right? So do a little code review before you use someone's crappy third-party library, right? Or misusing a third-party library, using it unsafely. Or one of the biggest vulnerabilities, not validating a user-driven URL. When a user URL is a parameter that you're going to render, this is one of the biggest holes in React. Google research tells me that untrusted URL parameters is over 1/3 of active attacks against their properties. And this is when you're using, again, you're rendering a URL that might be valid, but you're not validating it properly. So we're going to look at, in this presentation, cross-site scripting. We'll look at dangerous URLs, rendering HTML, securing JSON, dangerous styles, insecure native DOM access control failures, vulnerable dependencies, open redirects, and insecure server-side rendering. And by the way, hang out with me for a little less than an hour. I'll show you how to be a user interface champion when it comes to React. These techniques, if you know React well, this is not that difficult, right? It's just esoteric. It's a lot of stuff that a lot of React developers don't think about. And I ask you to spread the word to your team. In the world of API developers, we talk about what we're doing with each other. I see a lot of React folks get in their little world designing stuff. There's not as much cross chatter. So please talk to your team and show them this presentation and spread the word, right? So number one, let's look at real XSS. So cross-site scripting, a lot of people don't take it seriously, but here's some incidents that I remember very vividly. British Airways, somebody was able to modify a JavaScript library that led to 380,000 credit cards being skimmed and a big GDPR violation. Fortnite, which has a lot of kids playing this game, had XSS on a retired page that exposed sensitive data for 200 million users, many of them children. And eBay, classic, they had a URL parameter, something we're going to focus on here, right? That allowed attackers to inject malicious code into a page, giving them full access to seller accounts, manipulate listings, and steal payment cards. And eBay tried to fix this over and over and over again and failed to do it properly. So this major vulnerability was actively attacked for actually several years before they fixed it properly. Again, dealing with URLs as a parameter is a lot more difficult than it should be. So let's look at some XSS. Now, what I can do is, if you ever have a get query parameter that's rendered directly into a user interface, first of all, I don't recommend this, but I see it a lot. I can modify the parameter, send that to another user in a variety of different ways. They click on that link, and that attack payload will land in the user interface in that user. And I can steal tokens, I can sometimes steal cookies, I can steal any sensitive data off that page, and many, many more evil things with malicious JavaScript. What I see more often is stored XSS. This is where I'm implanting sensitive data into your database that has an attack payload, and you're using a React function like dangerously set inner HTML. If you're using the function dangerously set inner HTML on untrusted data with no protection, then what kind of life are you living? You're living dangerously. Thank you for, yeah, you're living dangerously. Sorry. Nobody laughed at my joke. I thought it was hilarious. All right, let's move on. With stored XSS, I implant the data in the database in some way. Another user visits a user interface page that renders that data raw or insecure in some way. Now let me show you some real-world attack payloads. I've had students go to jail using these payloads. Don't be one of them. So please use caution when using these real-world attack payloads without permission. It's illegal in almost every jurisdiction in the world. First of all, when we're testing for, and that's the other risk in React, view source to look at secrets, or injecting JavaScript into an app that another user is going to look at, right? So I inject sensitive data into an app, another user looks at that data, it has evil JavaScript, I own the browser at that point. And so when I want to test for cross-site scripting, I want to see if as an attacker, I can get special characters to render in a user interface unescaped. Can I get JavaScript, HTML, CSS, or any other markup to render in another user's web page that the developer did not expect me to do? One of the common ways to test for this is to use an alert, script alert 1. Now this is not dangerous, but if I can get an alert to pop in another user's web page, I have proven there's cross-site scripting. And so this is what it means to test for cross-site scripting. Most scanning tools you use in development will do these kind of tests and similar, right? There's another website, this is the XSS filter evasion cheat sheet that's many years old that will give you lots of payloads to test for cross-site scripting that are purposely made to evade input validation and evade web application firewall filtering. So all of these compensating controls, validating data in most cases, are using a firewall of some kind. These are not absolute defenses. And what I want to show you are absolute defenses. Here's an example of one of the original attacks to steal a cookie. This is a script I can inject into a web page, and if another user hits this page, I build a URL that I control as the, as the attacker. I grab a copy of the cookie, and I use an image object to send that cookie to my attacker server. It's one of the original attacks from the late 90s. It's trivial. You want your cookie to be HTTP only, so JavaScript can't read it if it's a session cookie. And the attack will still fire. HTTP only cookies shouldn't be necessary if you build React securely, right? Here's another one. Like, if you have any kind of sensitive data on a page, like a credit card that you're embedding on a page, which frankly you should never do, then I can use the same attack to build a URL, extract the credit card, and send it off to my evil collection server. This is how we use evil script to steal data out of React, right? And HTTP only is not going to help you here. Anything other than a cookie, I can extract out of a web application typically. Also, a lot of you developers, we developers are using local storage or session storage to store sensitive data. This is a terrible idea. One malicious script, and I can extract all data out of local or session storage. And here's an example of this using a fetch command to my evil attacker collection server. It's a trivial attack, and I can minify this to a really small size to have more places the attack is possible. So again, where's a good place to store sensitive data in a web application? That'd be nowhere. You render data and flush it from the cache and be done with it, right? For sensitive, secure applications. I can also force React I can also force React to make any request I want, right? This is the real attack that will do damage. This is same site request forgery, where I load a script, I create an image object, and I force a GET request from that page where the user is already logged in. The cookie goes with the request, and I'm able to force the user to make any request that I want. Once I can get evil JavaScript into your web page, I own that page. So I can also do a keystroke logger with evil JavaScript. I'm trapping the from character, I'm trapping the key down event and using fetch to ship it off to my collection server. And will the user even notice this is happening? No, these are quiet, silent attacks that steal data from the user. In the United States, we have American football. This is to make fun of the Patriots. And so the point of this slide is, look at document body inner HTML in JavaScript. I can use that to override the entire body of a web page, right? And make fun of my least favorite sports team, whatever. Now, the problem with JavaScript, it is evil. JavaScript is insane. If you gave me the gift of being able to go back in time once to fix history, right? That if I had that power, here's what I would do. I'd go to the birth of Brandon Ike, who wrote the JavaScript, the original creator of JavaScript. I'd take him as a baby, Brandon Ike, and beat him against a rock. Oh, sorry. Whoa, sorry. That's not funny. That's terrible. That's a terrible joke. You should never hurt babies like that, unless they're Brandon Ike. He wrote JavaScript, and it leads us to the pain that we feel today. Now, this is the point I'm trying to make is this is JavaScript. No letters or numbers. It's an alert. Did I just beat Brandon Ike as a baby against a rock? Did I actually do that on stage? No, I didn't do that, right? That's terrible. Sorry, Brandon, I'm only kidding. I would never actually do that. Yes, I wouldn't do that. So, okay, no letters or numbers. The point I'm trying to make is this is an alert in JavaScript. I can mess with JavaScript in so many ways to evade a filter. Or I can build a URL that's a URL that's starting an HTML tag with an onload or mouse over event, and this will bypass many of the very expensive web application firewalls out there. Or I can fetch a login page and override the action, so I'm popping your actual login page, but the password will be sent to an evil collection server from the attacker. These are examples of real-world cross-site scripting that we need to avoid when building React applications. So let's talk defense. React uses JSX, so does Vue and a few others, right? And it does auto-escaping. This is excellent. Any modern framework for user interface in the web should auto-escape, and React does this. But auto-escaping will not protect you completely. I'm going to show you one way that even when you're auto-escaping a parameter, I can still inject JavaScript through the auto-escaping of React. There's a relatively big hole. But what this does is, at the top, I have my attack payload being rendered raw to steal a cookie or other data from your web page. On the bottom, that's what happens when data is sent through your mustaches. It gets auto-escaped, right? The difference is the payload at the top rendered raw will execute and be invisible. The payload at the bottom that's been escaped by React, the code will be displayed on the page, but the payload will not execute. It will just display the code. That's the power of auto-escaping. It will display data exactly like the user typed it in without actually executing that code. Angular, React, Svelte, Vue, all of them, they do this. By the way, if you're a JavaScript developer and you're thinking, you know what, I could build my own user interface tech, and you want to build a brand new JavaScript user interface template language or user interface framework, I think you should be banned from development from 3 years. Okay, so next, so here, let's look at auto-escaping with React. It all goes down to the component, right? So I have create element. The first argument is a tag, a type. The second are your attributes, a prop. The third is the actual data. Now, the third piece of data, it will get escaped, and in most cases will provide security. But the first argument, a tag type, that gets rendered raw in React, and you should never use untrusted, unstrictly validated data for your first argument. That's a common misuse of React create element. The second argument is an attribute. It depends on the attribute. Some attributes are relatively safe, like an ID. That's a bad example. Some attributes are safe, like a width. You can't really attack through a width. But some attributes are dangerous, like source, href, on-click, on-blur, any kind of event handler. So if you're putting untrusted data into a safe attribute, you're good with the type. If you're putting untrusted data into a prop that goes into a dangerous attribute, now you have XSS and create element. And so here's an example of a component gone wrong, right? I have some props, I build a function, I'm putting it directly in an on-click attribute that will, whatever code, whatever data lands to handle click will be executed when that button is pressed. Here's an example of XSS I saw in an app relatively recently. When I think of safe attributes, I'm thinking of things like class, ID. Now, with ID, I can do ID clobbering. Rarely that's a problem. It's mostly safe. Draggable, context menu, char set, tab index. Most of these attributes are relatively safe to use as a prop with untrusted data. And these are almost safe, right? The problem with these is they're URL loaders. So if your URL is untrusted and not validated strictly, and you put it into an href, like a JavaScript URL, I'm back to XSS. These are only safe if you're doing strict validation. So let's look at some other dangerous React patterns. Create element, dangerously set inner HTML, JavaScript URLs, untrusted data being dumped into a styled component, embedding JSON as a performance pattern insecurely, and building React templates with server-side data in a variety of different ways. As a developer, so here, the intro is done. Let's get into it now. As a developer doing React, especially when you're doing complicated React, you need to master the art of 3 forms of security: validation, sanitization, and encoding. And these are all different things. Validation is when I have a rule that defines what good data is, and if that data doesn't follow that rule, we're going to fully reject that data. That's good validation. Sanitization, which you should almost never use, is going to take bad data and clean it up and then render it. This is dangerous in most cases, but in React, we need to use it for one specific use case. Encoding, which is built into React through JSX, will convert data to an equivalent form that's safe to render. And so let's take a look at this. When it comes to validation, if you give me a URL that's a parameter of some kind, you got to validate that strictly. Sanitization, if you're giving me HTML as a user that I need to render through a WYSIWYG editor or similar, I want to use HTML sanitizers. And when I want to render data exactly like the user typed it in, I want to, like for a CSS variable or embedding JSON or putting it through my mustaches, that's what escaping is all about. So let's look at dangerous URLs. This is the big one, right? This is the way like about a third of successful attacks work in the real world. So I got to validate these URLs strictly. So here's the use case, or here's the situation. Suppose you're doing social media and you're asking me to enter my home page. And then when you look at my profile, you're going to show my home page as a link, as an anchor tag, right? This is a common use case in social media or for user profiles. The problem is that the user homepage will get escaped, but an escaped attribute is still going to work and execute as a URL. So what I can do here is, if your only logic is to check if that data is, if that's a valid URL, that's a valid URL. JavaScript, document body, inner HTML, dogs are awesome, right? And so that URL will literally deface the entire page, and now, even through JSX auto-escaping, I just executed evil script because the URL, which you validated to be valid, is using the JavaScript protocol to execute that payload. Again, 1/3 of all successful attacks are using this methodology. And so here's another example of this. Here I have untrusted data as a payload. I have a button where the form action is that payload. The payload gets escaped, but the URL still works, and the URL has not been validated properly. There's another example of XSS through JSX encoding. And so I'll come back to that. So in fact, React knows this is a problem. React has had console warnings in React by default since React 16. And so, hey, a future version of React will block JavaScript URLs as a precaution. This is not default even in 18.3 yet. So use event handlers instead. If you need to generate unsafe HTML, try using dangerously set inner HTML instead. This is a bad error in the first place. This is not a good idea. So not only are they not blocking, the error console message is not very safe either. So we can't read that code, but here's the actual code where they're applying this defense. It's a big, ugly, regular expression. So this is the #1 way I can pop React with malicious JavaScript. What's the solution? My goal is for React to defend itself. I never want to depend on an API giving me safe data. So I can do server-side validation of a URL, but I'm going to follow the path of Angular. I want React to take an untrusted URL and do the validation in React itself. So I do something like this. I have this untrusted URL that I want to add into an anchor tag or similar. So I'm going to grab the URL, and I'm going to check if it's a valid URL in line 3. I'm going to make sure the protocol is only HTTPS. Those are my rules. It must be a valid URL, and it can't be JavaScript, it can't be data, it shouldn't be HTTP or FTP. So my strict rule here is that URL may only be HTTPS. And I do this in React before I render it. So even if an API developer makes a mistake and gives me an invalid data, that untrusted URL will only render if it's safe. And so my full way of, I make a little component that says the sanitized URLs in the href, target is _blank, and I say no opener and no referrer. It's a bit redundant. This is a safe way to render an untrusted URL from a user in an anchor tag. What else do we have here? There's same function, there's svelte. Let's look at rendering HTML. So we're pretty clear on handling untrusted URLs in React. You validate, make sure it's legal, and make sure it's only a safe protocol. And I recommend you make a component for rendering an anchor tag for that URL if that's what you need, so it's automatic when other developers are doing this type of programming. Next, let's look at HTML. This for sanitization. In the world of the web, we have good old tiny MCE. It's a WYSIWYG editor as a library. There's many others out there like Freola and the CK editor. This lets me do rich text editing. When I hit submit, it submits a chunk of HTML to the server. And then I want to grab the HTML and render it in React. So the problem, though, when you render data in React in your mustaches, auto-escaped raw HTML looks just like the HTML on the screen. So then I go Google, how do I turn off escaping? And the first result is, just use dangerously set inner HTML with no security guidance. I'm like, really? And if you look at that Stack Overflow hit, you'll see me in there as Manico ranting and raving that this is a bad suggestion, right? Anyways, so they're going to tell you, use dangerously set inner HTML. This turns off the auto-escaping. So my rule is, if I'm going to use dangerously set inner HTML, then I'm going to disable the auto. If I'm going to use dangerously set inner HTML, then I'm going to use a sanitizer. The main sanitizer in React is a library called DOM Purify. Like any third-party library, if you're going to use DOM Purify, keep it up to date. On the server, doing server-side coding, keeping libraries up to date is difficult. On the client, doing massive JavaScript work, keeping libraries up to date is nearly impossible of a task. I get interrupted 3 times a day with some library being up to date. This is why I minimize my use of third-party React plugins and similar to ease the third-party library update burden. It's part of our duty these days, even though it's awful. So DOM Purify has one function, right? Sanitize. It takes a big chunk of HTML and very accurately strips out the JavaScript and other malicious code so you can render it safely. And there's a lot of ways that you can configure DOM Purify. For example, it allows image tags. I can't execute script to an image tag easily, right? And so what it does is it lets me specify which domains are legal for my image tags and will sanitize out any URL that's not in my allow list. By default, DOM Purify lets you embed an image from anywhere, right? And so I can also do even more in-depth configuration of DOM Purify to limit where those URLs are allowed to land. Honestly, for the most part, you could just use DOM Purify raw and just allow it to clean any HTML and render it, and you're going to be safe from JavaScript execution. That's the main goal of that library. It does a really good job, but again, like any library, especially a security library, keep it up to date. So using dangerously set inner HTML anywhere in your code on raw data is a vulnerability. And what you want to do is go do a search. Go look for any use of dangerously set inner HTML. Take that content, run it through dompurify.sanitize, and that fixes the problem in most cases, right? What else do we have here? Let's talk about JSON. So one of the performance patterns from the early Redux documentation from the very beginning of React is I want to save a round trip. Even on a mobile network, even on 5G, there's a lot of latency, even though it's fast. What I mean by that is I make a request, I wait, and I get the data back fast. That latency, if you're doing like e-commerce and certain applications, a fraction of a second matters in some applications. So what I can do is I can embed the initial JSON at the top of the page and then render it immediately to save a round trip to the server. This is a common, for those of you who are really trying to squeeze out page rendering performance, you run across this technique, embed your initial JSON to save a round trip, right? And so I'll put JSON in a init state or preloaded state. And the original Redux docs told us just use JSON, stringify your initial JSON, and embed that at the top of the page. Unfortunately, this is very bad advice that rippled through the community, right? And so I can set my address to end the script, end that JSON bracket, open up a new script with an attack payload, and bypass stringify. Stringify does not encode. It renders JSON raw, and that's a problem. So if you want to render JSON embedded on a page safely, then what you want to do is basically encode that JSON. If you're doing Node, did I tell you that some people do JavaScript on the server on purpose? I know it hurts me, but I'm only kidding, Node folks. But I can either serialize it, I can use a JSON encoder, I can just use a straight up JavaScript encoder. I want to make sure that JSON is within quotes, a quoted string, and this problem goes away. It's typically pretty easy to fix. And it is a nice performance pattern. This matters in e-commerce in certain applications to speed things up. So I serialize my JSON, or I encode my JSON, or I just encode for JavaScript. Use JavaScript hex encoding. When I'm embedding JSON on a page, I put it in a JavaScript variable of some kind, and I make sure that JSON is in a quoted string, and this problem goes away. Next, dangerous styles, right? So take a guess why so many styled components in React have this CSS injection vulnerability. When I say CSS injection, here's examples of me injecting. Can I ask the folks a favor, please? Can someone grab me some water? I'm dying up here. It's my mistake. Can I beg the conference for a glass of water? Or gin? Water is preferred. Okay, so background image, background, PHP echo, get background. I can now modify the whole background image and inject code. Or I have a color where I'm just dumping in the user profile selected color. I can modify that whole CSS block. And so when you give me attacker-controlled CSS, here's a legacy attack. It doesn't work so much, but it gives you an idea of what these problems are. If I put an input type password when the value is A, I can, oh, thank you so much, you're awesome. I'm very grateful, seriously. I can say, if it's a password field and the letter is A, then send a request to any endpoint with the letter A in it. This is a keystroke logger in pure CSS. Again, it doesn't work so much anymore, but this is the kind of problems you'll run across if you let a user author their own CSS and you render it raw. Oh, I love water. There we go. And so here's how you know I'm not really Danish. You ready? I prefer water over alcohol. Wait for slightly. Okay, so default. Back, I thought my German friends could drink until I got to Denmark. Holy cow, you folks can drink. All right, anyways, default. Background URL. We have a URL cookie plus document.cookie. Here's another cookie theft or data theft attack in pure CSS. And so the answer is to use the raw JavaScript function CSS escape. And this problem goes away. When you have like a CSS value that's untrusted from a user, you run it through CSS.escape. But why do so many React component builders not use this? And the answer is painful, because this function does not work in IE11 and fails the IE11 test case. IE11 is dead. Is anyone developing any code on IE11 anymore in this room? I'll give you free therapy if you are. No, so IE11's dead, but we still have a lot of test cases failing because of it, because this function doesn't work in IE11. I digress. Here's CSS escape in action, where I have like a set property here with my variable, and I'm just CSS escaping the value. This is a native JavaScript function to allow you to put untrusted data into a CSS value. All right, let me rant for a bit. Please don't edit the DOM with the ref. What are you doing? React is elegant. There's many ways to render data. You never, ever need to use a ref to edit the DOM directly. Now, if you're doing programmatic focus, scrolling, or a click-away handler, I use refs for that. If I want to use find DOM node or a ref for read-only access, that's okay. But actually editing the DOM, you circumvent all of React security. Let's do this. Let's take a moment together and do security confessions. This is a chance for redemption and healing. Anybody? Who here wants to admit that they've used a ref to edit the DOM directly? Come on, admit to it. Do you want healing? Do you promise and commit moving forward you will stop using refs to edit the DOM directly? You are redeemed of your past sins. Let's move on. So Now, here's the thing, though. If you suppose you're like, yeah, I'm not going to do it, and you're crossing your fingers, and you're like, Jim, I can't stop, I won't stop, I love my refs, and you can't stop me, you PowerPoint jockey. That's a fair comment. So let me show you how to use refs properly. If you're going to ref to modify content, here's how you do it. Text content, insert a JSON text, use set attribute with one of the safe attributes only, create text node, create element. These are all safe from JavaScript injection. And if you've been listening, if you're using inner HTML on raw data, that's a major vulnerability. How can I put untrusted data into inner HTML safely to avoid JavaScript injection? How can I put data into inner HTML safely? What library do I need to use to clean up the mess? DOM Purify. So if you're going to use inner HTML in your ref crazy world, then use DOM Purify to sanitize. I was looking at a legacy React app with many bugs. All that we did was we took DOM Purify and ran it against every variable entering the app, and it fixed the problem. We were live again in a relatively short amount of time. This is a great library to help you remediate some legacy insecure code. And remember, there's our safe attribute list. These are attributes that don't execute JavaScript or don't load untrusted URLs. These URL handlers are safe if you strictly validate the URL, domain, protocol, and make sure it's legal. Let's talk access control one more time, right? Avoid any access control in client-side React. And this is, again, it is rare when I see developers follow this. But keep in mind, again, I got view source, I see all your forms, all your links, all your data. I saw this one app recently by a really smart team that delivered JSON to the browser with all kinds of sensitive data that the user did not have access to, and then used JavaScript to limit what they could and could not see. This is not going to work. I can view source or just intercept the response. So you want to follow the principle of least privilege incredibly strictly. Only give me data, code, links, everything that I have access to only. And so this is why I typically build one app for my normal users, another app for my admins, and I have completely separate apps for privileged users. I have no choice if I care about security. And this is the early principle of least privilege from Jerome Salzer from like 1976, I think, where every module must be able to only access information resources that it requires and no more. This is a very big and common design flaw in the React development world. And so if you really want to combine applications, if you really want to make a user interface that has a variety of different access control levels of access, one thing I have seen some developers do is called lazy loading. This does not expose any code to the client. It will dynamically load what it needs only. Then I do strict access control at the API level, so I can't feed anything to React that that user doesn't have access to. But typically, I'm building a separate app for admins, a separate app for normal users, because if I merge those together, it leads to all kinds of exposure in the access control world that should not happen. Hey, how much time do I have left? How am I doing? Can I get a time? Hey, NDC. 5 minutes? 15 minutes? 25 minutes? 15, okay, great. So let's look at third-party libraries, right? In the world of React, all apps should try to use the latest version of React, right? We saw a flaw back in 0.14. I still see people using that version of React in the legacy world. And so, again, and also the other problem here is that we see like a variety of different JavaScript modules added on a daily basis. What's the JavaScript module ecosystem? Remember what I said? A morass of insecure filth. That's the majority of it. It's just the truth, right? So you got to be really careful about what you're using in the world of JavaScript. These third-party components, they have no security guarantee. Always do a security audit of your third-party component before you use it. I'll show you a few things to look for. And just because a component is popular or has a lot of stars on GitHub, woohoo, it doesn't mean anyone did a security audit. You want to use automation and scanners and similar to make sure these components are up to date and not vulnerable. So when I review, so again, these third-party libraries have issues, check your dependencies. When I'm reviewing a third-party library module in the React world, I first look for the use of dangerously set inner HTML on raw data. If they're doing that, they're out. If they're using inner HTML on raw data, they're out. If they're taking URLs as a parameter from a user and rendering them with no good validation, they're out. Or any other unsafe patterns we talked about in this presentation. Also, avoid libraries, if you can, that insert HTML directly into the DOM. I still do that because it's my habit, but there are better libraries like React Markdown that use the React API to construct elements rather than dangerously set inner HTML. So Markdown still has problems, but I go from Markdown, I use a WYSIWYG editor, HTML, to Markdown, Markdown to React API function calls, and the performance is actually better and less chance of security problems. So that's my preferred pattern. I don't use it myself, but I at least look at libraries that do this, and they're out there. And so there's some tools you can use. There's a great, Erlend Oftal from Norway wrote retire.js, which will let you, as a browser plugin, detect if you're using insecure libraries. We also see just straight up NPM audit will force update your whole JavaScript stack. And ESLint is amazing. I code with ESLint with some of the security plugins turned on, and it radically helps me build better code. One sec here. There we go. One more issue. Thank you so much. Open redirects is also a problem in React. So what's the problem here, right? I have a URL parameter that we're going to redirect to after the user is done logging in. This is a common pattern in a login mechanism, right? I have a bookmark. I hit the bookmark. I'm not logged in. You redirect me to the login page. You take the previous URL and put it as a parameter. I log in. You redirect me back. But the problem is I can just modify that and make it an evil URL. And I'll give you this URL. You log in. When you're done, you go to my evil website that has an exact copy of your login page and says login failed. You log in again. I got your password. I redirect you back to your home page, and you're logged in because of this bad parameter that you're not validating. And so redirects are used to establish a user-friendly flow here, right? And here's this pattern I was talking about. I have a URL that has an evil redirect parameter for login. In step 2, they load the page. That's your login page. They log into your login page successfully, but then redirects to my fake login page because I can manipulate the redirect parameter. It's the exact copy of your login page. I collect your password. I redirect you back to the original site, which says you're logged in successfully. And without even realizing what happened as the attacker, I just got your password because of that one unvalidated URL. Now, how do I validate a URL? It's not easy. I can use something like this if the URL contains a domain, but that domain could be all kinds of things. It could be a get parameter, a subdomain. Dealing with URLs that are untrusted is a much more difficult problem than anyone would have thought. It's such a big problem that the OAuth 2 standard body said, stop validating URLs. Stop it. Just use basic string matching and use an allow list of valid URLs. If you have a wildcard subdomain, I can put a whole different domain in there, and similar problems have showed up that are extremely brutal. So when I want to secure a redirect, I use a basic allow list of valid URLs. If you don't match that, I ignore it, is usually the best path. So here's an example of a secure redirect list. I'm only allowing redirect to those 3 endpoints. If you're in the list, I'm going to redirect you. If not, I'm going to either take you to the home page or just error you out. So unfortunately, doing things that are very dynamic with redirection usually leads to security problems, and I try to avoid it. coming to the end here, insecure server-side rendering, right? When it comes to SSR, now we're in the world of Node, where they write JavaScript on the server on purpose. Yeah, exactly. So server-side rendering, this is all about using this is an awesome, blazing fast performance pattern, right? I'm going to use all the render2 functions to assemble HTML on the server and send assembled HTML to the client and let my server-side big engine take care of all the work. This is an interesting pattern. I've been playing with it lately. I like it. But the issue is you can't mix the render2 functions with the raw variable. That's the problem. You cannot mix the render2 functions with the raw variable, and I see this a lot. So it's actually easy to avoid this problem, but again, I see a lot of this in server-side code. The other deal is all the other security best practices that we talked about, you need to apply those when doing SSR like any other React code. One more thing here is a lot of folks in the like the old school world of doing server-side templates, they now want to migrate to React. And when I'm seeing that kind of like Java server page, active server page, PHP template migration to React, I see this a lot. They're grabbing a parameter from the user and they're using it in the middle of a template. And that's a problem. React templates are not meant to be rendered dynamically on the server. They should be relatively static, sent to the client, do a round-trip JSON, and then populate. So this name parameter, that should be delivered over JSON to the client. But this developer is migrating a Java server page to React, and now I can inject any JavaScript I want into the name and mess up the template and inject evil JavaScript. So please avoid dynamically creating React templates with user data. So last but not least, client-side logging. I've been doing a lot of logging in React, and the only note I want to make here is if you're going to do React logging, make sure the API endpoint that's collecting your logs is not going to be a performance bottleneck. So in React, when I kick off a log, I don't use a blocking function. I kick it off asynchronously, so if the log endpoint is being throttled, that it doesn't affect the React app. I also make sure that on the server, only authenticated users can hit my logging endpoint. Public logging endpoints are asking for trouble. Anything else we want to talk about here? I think we're nearing the end of this presentation. A few final notes, right? I highly recommend, what did we talk about? We looked at all of these different categories, right? We looked at basic cross-site scripting, dangerous URLs, rendering HTML, securing JSON, styles, insecure native DOM, access control failures, vulnerable dependencies, open redirects, insecure server-side rendering. These are the categories we talked about from a defensive point of view. I have a few minutes. Does anybody have any questions about anything we talked about today? Any questions at all? Yes, sir.
We recently started using content security policies.
Awesome.
Are there any pitfalls to using them?
I would use a nonce-based policy and avoid allow listing. Allow listing, Google research showed me that 94% of content security policy allow lists were bypassable in some way. That's CSP1. CSP2 allows you to use a nonce. So in the header, you'll have a nonce value, drop the allow list, and for every script block and script loader, drop the nonce in. That's going to be a much more robust way, and frankly, easier way to roll out CSP. The only trouble is if you nonce a library, it's not going to pick up all the dependencies. So you want to use a modern library, nonce the library, and then use the CSP3 call, strict dynamic, that assumes you're keeping your libraries up to date, and if you nonce one library, it will automatically let all the dependencies load. So this is known as very strict CSP from Google research. Use nonce, drop the allow list. It's basic overall recommendation, right? There's always exceptions. Use an allow list, avoid the allow list, use a nonce, and if you have libraries with many dependencies, then use strict dynamic from CSP3. Even better, use prime libraries with very few dependencies, drop strict dynamic, and nonce all the libraries you need is going to be the strictest form of CSP, and then many of these JavaScript problems, even if they execute, CSP will stop these problems. But still, write secure React. CSP is a compensating control. Any other questions? Good question, by the way. I hope this presentation was of use to you. A few last notes. Use ESLint. I use ESLint with the ESLint security plugin and the React plugin, and for free, it will pick up a lot of these issues and flag it during development that I'm making this mistake. The earlier you find these problems, the better by far. And so again, use a linter to check your code. I think ESLint is the best. If you have questions for me beyond today, you can reach me at jim@manico.com. I'm a local resident here in Copenhagen now. I'm really happy to be here. Thank you so much for listening to my presentation. And hey, enjoy the rest of the conference. Go forth and write secure code, everybody. Thank you so very much.